afternoon, everyone, and welcome to the 33rd episode of MSME Masterclass. Today, we will discuss steel structures with prefab walls for sustainable development, which is nothing but construction technology, with our esteemed speaker, Dr. Abhay Gupta. Dr. Gupta is one of the directors at Skeleton Consultants Pvt, which provides consultancy on integrated project delivery from concept to commissioning in the industrial sector across Delhi, NCR, Indore, and Kochi. He has more than 40 years of experience in civil engineering construction and structural design, along with teaching research with several academic R&D institutions and BIS. Dr. Gupta obtained his BE in civil engineering, followed by his ME in structures from SGSITS Indore, and his PhD from the University of Roorkee, which is now IIT Roorkee, in the area of aerodynamics, interference in tall rectangular buildings, wind tunnel studies. He is a dynamic, multi-dimensional civil and structural engineer with vast experience in RCC and steel designing, construction management, teaching and research, and team building, imparting leadership to a group of people in pursuit of achieving individual and organizational goals. He currently has experience in the design coordination, review monitoring, and execution of more than 500 projects of RCC steel in the building industry and infrastructure sectors. Join me in welcoming Dr. Gupta to our masterclass. Welcome, sir. Welcome on board.
Thank you very much for this wonderful opportunity. Thanks for generous introduction. I'm happy to be here.
Thank you, sir. So we will move on to our first question for today, which is, what are the key advantages of using steel structures with prefab walls, and that is over the traditional construction methods for MSME projects, sir?
Very relevant. Traditionally, we have been constructing using the brick mortar and cement concrete. And as we all know, mostly raw materials from the locally available area is there. And then we do on-site construction. Means everything, all raw material is assembled on the site and then converted to a construction shape form. But when we do the prefab construction, anything prefab or pre-engineered or pre-constructed means something which has been made somewhere else and brought to the construction site and assembled. So the technology which we are going to talk about today, steel structure with prefab wall, is all the components are made somewhere else and then brought to the construction site and assembled. So this technology has got many advantages, primarily because we are not assembling the material on the site. So we are reducing on the wastage, reducing on the manpower, reducing on the overhead, and so on and so forth.
Okay, and sir, how does this construction technology contribute to sustainability, particularly regarding material efficiency and waste reduction?
Additionally, the construction which we do, bringing all the raw material at site, number one aspect is wastage. So in a steel construction with prefab walls, we are reducing the wastage. So that is one of the major aspects of the sustainability. Second big aspect is use of water. Sustainability primarily focus on conservation of the natural resources. Water is one of those resources which is scarce. So in the steel structure and prefab walls, we are avoiding or minimizing the use of water and wastage of water both. When we take the cement concrete and do the traditional construction, then we use lot of water in making of concrete, making of mortar, making of masonry, and then curing. Huge water is wasted in making and curing also. So all that is saved, and that is one of the major contributor in the sustainability. Another thing is durability. So whatever material we are using in this technology, that is all tested under several parameters, under strict quality control. So they are all durable material. So longevity is there, which contributes to the sustainability. And fourth, one of the most important thing, that all these materials which are used in the steel construction with prefab wall, they have a scrap value, huge scrap value, which otherwise in the traditional construction is a minus, negative scrap value. It means you have to invest money or spend money to remove them or replace them. In steel structure and prefab walls, you are not spending, but rather you get back a lot of. So that scrap value is another a positive aspect of the sustainability.
So, sir, let's talk about life cycle analysis. Could you explain to our attendees the environmental impact of this technology compared to the conventional building materials?
In conventional building material technology or conventional construction or the business as we do, that we more oftenly term as, we bring raw materials from various places to the construction site. So there's a transportation involved. The moment there is transportation, lot of dust, dirt, pollution, fuel, all those things get involved. So that pollution is there with the traditional construction, which is completely avoided here or say minimized in this. Secondly, when you do the construction on the site, then there is dusty environment which adversely affect the environment and causes the harmful effects on the labor working there, which is completely avoided in a steel structure and prefab, where there is absolutely neat, clean, methodical working, where each and every component is identified and is picked and assembled. So there is no pollution on the site per se. So environmental impact of the construction, if I say, it is significantly changing from the polluted atmosphere, dust environment to the neat, clean and organized construction. Another factor, another parameter, if I say, of the environmental impact, that when I use cement, then I disturb some of the natural raw material resources, calcium, limestone and all those things. I'm using sand. Sand is one of the natural resource which is again to be conserved. Mining we do, we are disturbing the you can say mountains, we get hillocks or natural deposits or the forests also. Aggregates, I mean the stone we are using. Cement manufacturing takes a lot of natural resources. And then what? But in case of steel and prefab, though we are producing them in factory where there is a lot of heat generation, but again the overall contribution towards the environmental pollution is only limited or confined to a particular place where there are stringent measures to control them from spreading out. So that helps in controlling the environmental aspects. So in that way, environmental impact of steel structure prefab wall construction is much less as compared to the traditional concrete and masonry construction.
Understood. Well explained, sir. Because you touched upon cost as an element, we wanted to ask you, what are the typical cost considerations when selecting prefab walls with steel structures, and how would they compare to traditional building costs?
Whenever you switch over from a locally available material to something branded, initial costing is more. It is true in case of not only buildings, but in case of everything. Even with the garments which we use, clothing or other things also. So same thing is here also. I am switching over to a better product, which is branded. Brands are like the one which you are displaying, JW, the other is Tata, and other brands are there. So you are switching over to the branded thing. When I talk of prefab walls also, so prefab wall means they are factory made product. On the other hand, I am using locally available raw material. So I have to pay a little more. So initial cost of a steel structure prefab construction is little more. Little means it is sometimes in the range of 8 to 10% more than the conventional construction. However, overall weight of the structure reduces when I am using the steel and prefab because they are lightweight, because they are functional. Okay. In traditional construction, we have been consuming lot of dead weight of the material. If I give you a data, in the traditional construction, the live load which comes on the structure, if suppose that is 200 kg per meter square or 2 kilonewton per meter square, then the self weight of the structure which is resisting this live load is almost 12 to 14 kilonewton per meter square, means 6 to 7 times. While using steel and prefab wall, that self weight reduces to 4 to 6 kilonewton per meter square. That means I am bringing it down to half or less than half. So when the overall weight reduces, my design becomes optimized. My design becomes light. I am putting less weight on the earth, Mother Earth, and my foundations are lighter. So overall, foundation cost reduces. That is one thing which is already accounted for in the 8 to 10% of the increased cost, initial cost. But at the same time, on the life cycle analysis, if I do, I am getting a more reliable product because everything is factory made, tested, quality certified as per certain Indian or international standards. So I'm getting a quality product. So more reliability is there. So I'm getting a more durable product. Another good thing about using these is assured life of the structure. On paper, we say concrete structures or the masonry structures we design for say 60 years of life. However, due to environmental factors and ingress of the moisture and other thing, we have seen many concrete structures start deterioration quite early, where the same thing in the steel and prefab wall is assured that it will last long. So that 60 years of life is guaranteed. Even many of these steel structures we see, they are as old as 100 years of. So these are the advantages on the life cycle, and then the maintenance cost per year is less because these are properly treated material. So my maintenance cost is less. So annual cost of maintenance is less. So if I go at say 20 years cost, 30 years cost. So initial cost, capital investment plus the maintenance cost per year at the end of 30 years of a traditional construction, conventional construction would be higher than the same of the steel structure with prefab wall. Okay.
Understood. So, because you touched upon a very important element, which is durability, we would like to understand more of it in terms of what are the critical factors in designing and engineering these structures to ensure durability and structural integrity.
Very good. Our design codes, which we use for the design of the RCC or the concrete structure, we say with steel structure. They themselves, when they define the safety factors for the design, then the safety factor even on the steel structure is lower as compared to the concrete structure. That means if you know some material better, if you are sure of its performance, if you are sure of its quality, then you tend to utilize a lesser factor of safety. So I get a better design. The steel structure is having higher strength to weight ratio as compared to the concrete structure. So that helps in designing better. Correct? These things, as far as the atmospheric ingress is concerned, because RCC, the conventional concrete, is a heterogeneous material. We mix certain compounds and we depend on the quality of the gel formation, which gives the strength. Now that again depends on the quality of the water which has been used. And we all know that the water in our country is varying in its quality at different places, and there is a lot of contamination to the water. So unless and until the water quality is assured or it is of a required standard, you may end up into, we can say, adverse effects on the quality of the final product, which is concrete. Secondly, we are inserting reinforcement. We are putting reinforcement in the concrete. Now reinforcement means it is a foreign material. That foreign material reinforcement is embedded or is used in concrete, and then we call it RCC for the purpose that there are some good qualities of the concrete, some good qualities of steel. Together, RCC will perform better. But what happens when concrete is a porous material, and when the porosity is there, moisture attacks inside, and the steel bar starts corrosion, that starts rusting. Once that starts rusting, then the cracks develop in the concrete structure and adversely affect the durability. While these things do not happen with the steel structure and the prefab walls, which are completely sealed, completely homogeneous production there. Except steel is affected by two things. One is fire and one is the corrosion in the aggressive environment. Suppose there is a sea coast nearby, then I have to take some special care to protect that steel surface. As far as fire is concerned, yes, steel being strong, so the section sizes are thin and slender. So there we need to be careful about either using some fire paints or covering them with fire-rated board. So these are two precautions, but it is all well known, so we can plan for that and impart into that. And once done, then the durability of steel structure prefab walls is assured for a longer life. Yes.
Correct. We were actually moving on to the climatic conditions part only, sir. So we want to understand from you, how do these structures perform with regards to energy efficiency and thermal insulation, especially in diverse climatic conditions across the country?
In a construction, larger area is occupied by the walls. These walls in earlier times used to perform, or they were used for few objectives. One of the objective was privacy. One was protection from the external environment. One was, you can say, sound protection, heat protection. One was safety. Okay, nowadays, for years together, we have remained dependent on these. But now there are several good new materials which are available. I will quote one organization, Building Materials and Technology Promotion Council, BMTPC, which also helps MSMEs to a large extent. If you look at BMTPC overall program and their website, they are supporting MSMEs in developing these new technology materials. So all these new technology materials are tested under a specific set of the conditions, environment, for performance. And they issue a performance appraisal certificate, PACS, to that scheme they call. And many of the MSMEs have developed products and they have got their product registered. So each of these prefab walls, which are hardly 70 to 150 mm only, while the traditional brick walls are 150 to 300. Correct. So we use these drywalls depending on the intended purpose of thermal insulation, heat insulation, acoustic insulation, environmental protection, those things, and privacy and strength. So these new, you can say, researches in the technology, they are leading to development of such products which are high performing products, I'll say.
Got it. Now, talking about regulations and certifications, sir, what role do they play in adopting these construction technologies in India, and what are the current challenges?
The prime body of formation of the rules, regulation, policies is Bureau of Indian Standards. Bureau of Indian Standards has developed, as issued one document called National Building Code of India. National Building Code of India covers materials, different type of their properties, their stresses to be utilized in the design procedures, and performance scales, performance parameters for every kind of structure. So that Bureau of Indian Standard approves. As far as approval of the plans particular to any area is concerned, that is governed by the local authority, like Municipal Corporation of Delhi, or like Directorate of Town and Country Planning of Haryana, like Mumbai Municipal Corporation. So these are the local bodies which checks the local bylaws as far as the construction is allowed, permitted, approved. But as far as the usage of the materials is concerned and their design is concerned, that is guided by the National Building Code or Bureau of Indian Standard. At the same time, some policy formation is also coming from Bureau of Building Material Technology Promotion Council, BMTPC. So there are very good documents available in the terms of not only IS codes, but also in terms of the guidelines and manuals for usage of various building products like steel structures. We are using IS 800 code. For steel sections, we are using IS 20 code, 2062 code. For reinforcement, there's a different code. For drywalls also, there are new guideline documents coming up this way. So these all things help us in checking the permissible material, their stresses, as well as the local authorities, they define the bylaws for the construction in terms of the area, coverage, height of the building and other things.
Got it. And so what advancements in technology and manufacturing have contributed to the growth of steel structures and prefab walls?
Traditionally, steel structure was being used in this country or across the globe rather steel was one of the very old material which was used in the construction. We all see railway stations which are totally made of the steel. We see some water tanks, we see some industrial buildings, all made of. But traditionally we have been using rolled steel sections, available rolled steel sections made by various companies like Tata, SAIL, JSW and other companies. And there were documents. But in last 15, 20 years or 25 years, there have been significant, or I'll say paradigm shift in the thought process and technologies, and we have modified our steel sections from the sloping flanges to the parallel flange section, which are more efficient. Section dedicated for vertical column usage for the long span usage. We have also used new machineries and equipments which can customize these steel sections. Means plates are there, high strength plates are there. Earlier we were using mild steel, which was having a yield strength of say 250 megapascal, Newton per mm square. But now new technology has made possible for the development of 350 and 450 MPa steel. Means from 250 to 450 is 80% enhancement in the property, the characteristics of the steel. Beyond this, not only strength, but fire resistant steel, corrosion resistant steel, high performance ductile steel for earthquake resistant design. These are also new products which have come up in the market. There are new machinery. Earlier in India, why steel structure were not so popular? One of the reason was limited availability of the steel sections. Second major factor was welding. We were not having proper certified welders in the country. The welding technology was not very well developed. And in steel structures, whatever prefab structure, you take a good product, but ultimately you have to assemble 2 or more components. So assembly means you have to develop a connection. That connection has to be properly made, but we were not good at doing that. Either by welding or by high strength fasteners. We were not having that technology also in the country. Now we have developed a whole lot of certified welders, good machineries, welding machines, automatic welding platforms, good quality of fasteners from other countries and now plants in India, very good quality, high strength fasteners, and then their plants to make connections properly. This has helped, or this has promoted usage of steel structures in various types of construction. You see, nowadays we see new airports. So beautiful steel buildings are there. You can see circular hollow section, rectangular hollow section, which were not there 10 years back. Companies like Jindal, companies like APL Apollo, they have made wonderful plants for these sections, which are very efficient in terms of strength and performance. So new sections, new technology, new skill development has allowed us to use steel for any kind of structure. And best examples are good airports, new railway stations. The country has announced almost 500 plus redevelopment of new railway stations. When they are huge, like airports, terminal building, they are all being made in steel. And I'll talk about that a little later, about the other advantages of the steel construction. But steel is giving that, the technological advancements on the steel section. The prefab walling has become popular in last 5 years or so. I remember we did a project in Jammu about 8 years back. It was all steel building, residential, India's largest residential high-rise complex where there was no brick or concrete above the ground. Paradise Avenue in Jammu, 14-floor building complex, and all the walls were prefab walls. So they were not actually those new technology prefab, but there were partition walls. Those boards used to come from HIL, Aerocon board used to be there. So we used that. We used light gauge steel construction and board on both the sides. They were also a type of the prefab walls. But from then till now, I know that at least 20 varieties of different type of walls are there with different characteristics. Means now we have very well understood that what are the functions required, what are the performance parameters of a wall. So accordingly, we can add different new materials and bring out a new product. So at least 20 such new products I'm aware about. They are available in the country and we have been using them.
I was actually coming to the case studies that you can share with our attendees as examples of these structures being effectively utilized in sustainable projects in India.
As an individual, I have always remained pro-steel. Means I have always been thinking, any structure I see, I think I can make it in steel. Since years. And with that thought process, when I started my teaching, I was the professor of steel structurals. So to my students, I was taking to the construction sites where I could show them some steel structure. But I could not get that opportunity in those early days. I'm talking about 1984 to 1996 kind of period. But beyond that, when I left teaching to voluntary retirement and started consultancy from 2007, I know that I have made almost every kind of structure in steel, starting with statues. We have made gigantic statues. To tell you, 351 feet high Lord Shiva statue in Nathadwara near Udaipur, one of the world record. Its design life is 250 years. It's a wonderful example of a steel and concrete hybrid. So entire internal structure is steel, made with the parallel flange section, universal beams and columns supplied by JSPL, and the entire skin, external skin, is a cast in situ concrete skin, high performance concrete. So both the worlds together, concrete and steel, but that's a steel. Another, we are doing Dr. Ambedkar statue, 351 feet high in Mumbai. That's completely steel, like Sardar Patel statue. The main frame is steel, so human organ shapes are there. They are not possible with the concrete. We did a wonderful structure in a hospital between Vallabhgarh and Palwal. It's a Sanjeevani Satyasai Cardiac Care Center. It's a heart-shaped hospital, 150,000 square foot area, 3 floors, and you will be surprised to note that the entire hospital, from the first day excavation started to first surgery performed, was 273 days, 9 months. Finished with all equipment. So that is the speed you are achieving. Case studies, if I tell you latest case studies, we are working on 3 lighthouse projects in the country to bridge the gap between demand and supply in the housing sector. You know that a lot of population is shifting from rural areas to urban areas. By 2030, almost 40% population of India will be urban. So 150 million, and then if I talk about 30%, it will be 45%. So that to accommodate that, you need housing units. And traditional construction will take years for construction. So these lighthouse projects launched by Government of India Prime Minister Awas Yojana with the technological support from BMTPC, we have made Indore, Agartala and Lucknow. These 3 locations, high-rise housing with steel frame and 3 different type of prefab wall technologies. So lighthouse project LHP Indore, LHP Agartala, LHP Lucknow. LHP Indore and Lucknow have been handed over. LHP Agartala is in progress. But beyond that, we have done hospitals, we have done hotels, we have done residences, commercial buildings and whatnot in steel. Everything possible have been done. Nowadays, we are working on some good railway station projects, which are again new modern age railway station. So these are some of the case studies which will certainly encourage our dear friends from MSME industries that they can find a role into that. every
That's
such construction will attract them.
That's wonderful, sir. Thank you. Thank you so much for sharing this. Now we have a question from the audience on the logistical challenges in transporting and assembling these structures, and how can we overcome these challenges?
Challenges about the construction, you're saying?
Logistical challenges in transporting and assembling
Yeah,
these.
so means entire process.
Yeah.
As again the conventional construction where all the raw material is on the site itself and you just bring lot of labor and mix the material or assemble and put one by one, brick by brick, and you construct. Against that, in a prefab, you treat this as a product. This is not a construction site. This is a fact. This is a product basically. So when there is a product, it has to be made in a factory. So all the components of a prefab steel with the prefab wall construction, they are produced somewhere in the country, and you can bring them to any site in India using the local transport available. So one of the prime parameter is transportation. Before transportation is the manufacturing. After transportation is the assembly, erection. These are the three major segments, and that is why the entire scenario of the construction has changed from manual or on-site construction to mechanized off-site construction. Means a lot of machinery is involved. So as far as logistic challenge is concerned, yes, when you want to transport anything in this country, normally the size of the component should be 6 meters. So like 1 floor, 2 floor components are transported, and then there are nut bolt connections and they are connected. Beyond that, in special case only, but otherwise logistic. As far as erection installation is concerned, on site you again need cranes, hydra and other big cranes, and for shifting also. So that is second aspect of prefab construction, that you need some more machinery and equipment. So this is the difference from the traditional construction, that these are the challenges which we have to some extent successfully overcome today. Good roads are there.
Does that impact the construction timeline and project delivery schedule?
Significantly, if I say. Significantly. You can surely save 40 to 50% of your construction time. 30 to 50 if I say. If it is a small project, then you can say 30% saving. If it is a big project, 50% saving of time is there. Proper planning. Nowadays, this entire thing is also supported with new softwares, 3D softwares, building information modeling, where you can visualize, you can virtually construct every building before it is really constructed on site in the computer. Means right from the place of production, how the production will take place, their component marking, how they will be assembled, they will be stacked, how they will be shifted one by one, what will be the truck lots, how they will reach, what will be the erection sequence. Everything is virtually defined in today's world's 3D, these new software. And then things become very easy because you know each and every component, it is status, when it is to be transported, so you don't unnecessarily require space on the site, and you save on time, you save on overhead costs.
Understood. And so what are the maintenance requirements of these structures, and how do they differ from the traditional building maintenance practices?
Concrete structure require regular maintenance because in India we do cement plastering on the concrete and brick, and plaster is a porous material. So plaster has a life. Plaster has a life like any paint or color. Whatever good quality you do, you need to redo it after some years. Sometimes 2 years, 3 years, 4 years, and if it is exposed in the environment, maybe every year. leakages, seepages of the water also causes damages to the surfaces, and then you need maintenance. So you need painting, you need repairing of plaster, you need continuous monitoring with respect to corrosion of the reinforcement and cracks in the concrete. You need to monitor the leakage, seepages from the toilets and terraces, everything. Correct? These are the areas of maintenance for the conventional construction. Whereas in case of the steel with prefab wall, all the walls, all the connections are fully sealed. And that is why there is no gap available. So when there is no gap, there are no leakage, seepages, number one thing. Secondly, your steel structure and prefab wall, they do not have any peel off material. So the paint even does not go in less than 5-10 years. If at all you have to redo, it is a longer period. So the maintenance is, but yes, there is one aspect that you are connecting two components. Now these two components with time may get looser. So you need to monitor all your connections at regular interval. That's a precaution. Secondly, the material which is used at the connection, sometimes they may open up, the joints may open up. So you should keep an eye once a year to check if there is anywhere any joint opening or looser. That's all, nothing more.
And what are the typical considerations for integrating mechanical, electrical, plumbing systems into these structures, and how does this impact project planning?
In conventional construction, generally we start thinking about services at a later stage, not from beginning. But yeah, okay, not an issue. We'll drill a hole. We will change a raceway. We'll put the pipe after construction. We don't bother. So integrating of services like concept is not there at all in the convention. We say, okay, let's make and we'll see. Even if we need to damage the structure, we'll do. That is the bad thing about the conventional construction. That has been completely addressed in the prefab. Because in prefab and steel, you just can't drill a hole anywhere. You just can't cut a chase for the conduit anytime. So it has led to one very positive aspect of this construction, that you need to do the pre-planning about the services. And that in turn also helps in saving of time and cost. So you do a pre-planning of services and you can put the pipes, conduits inside the prefab wall well in advance. So then it leads to a plug and play kind of the arrangement, where wall is fixed and now those you can say openings are available where you have to connect the external services. That is then. So it is very easy, and with pre-planning all drawings are ready and can be done with. Again, this helps in saving of the cost because wastage is not there.
Can you also highlight the role of prefabrication in enhancing safety on construction sites, especially when it's concerning labor practices and site management?
Very, very important aspect, and it has really helped. Steel structure and prefab construction with mechanization has really helped in enhancing safety of the workers at site. The accidents have reduced significantly because all components are defined, all components are handled by machines and equipments. So unless and until an operator makes a mistake, generally there are no accidents. Already human labor is reduced on the construction site, so less chances of accidents are there, and whatever manpower is there, that is much more skilled and literate as compared to the unskilled one, which is used in the conventional construction on site. So more awareness is there. A level of education is increased. less number of people are there, so vulnerability is reducing. And introduction of machinery has certainly helped in ensuring more safety on the construction sites. There is no clutter, there is no raw material unnecessarily stored on the site, which is sometimes one of the reasons of the accidents. It's not there.
Correct. Correct. And so, how do these structures address the housing shortage issue in urban and rural areas of India, particularly in the context of sustainable development?
It is one of the big problem which our government is trying to address since last almost 5 years. A study by Ministry of Housing and Urban Development showed that there is a migration of the population from rural area to urban areas because of the employment opportunities, because of the education, because of many other factors. Okay, because of the better livelihood available. And by 2030, as I said, 40% population would be in the urban area. The gap is in millions of houses. It is of the order of 11.2 million about 3 years back in the urban areas, and which is targeted to be bridged in 3 to 4 years as the program has been made. So for that, it is very necessary that rapid mass housing be implemented. The rapid mass housing is possible with the vertical expansion, that is number one. Secondly, with the off-site or prefab construction. So these projects which I mentioned, lighthouse projects, there are 6 lighthouse projects which have been launched in the country. 3 are in the precast concrete, Jharkhand, Ranchi, Chennai and Rajkot. They are the precast concrete, whereas Indore, Lucknow and Agartala, these are prefabricated steel and prefab walling technology. Building Materials and Technology Promotion Council has identified 54 new technologies, which they have mentioned on their website also, along with the performance appraisal certificate. And most of these have been granted or they have been started by MSMEs only. That is one of the very positive aspects of it. So those 54 technologies have been grouped into 6 categories, and these 6 lighthouse projects. 3 are in steel, and in 1 year 1040 flats at each site. That is the target. So in next 5 years at many sites these will be started for urban poor. There are 300 square feet dwelling units, 1 room, 1 bedroom and 1 kitchen, 300 square foot standard, where they can comfortably live in high-rise buildings. They are from like 5-6 floors to 13-14 floors. So this is how this entire thing will help bridging the housing demand in the country and reducing the slums. See, another good side effect of this is that you are maintaining the aesthetics of the city.
Right. And sir, how can MSMEs collaborate with architects, engineers and suppliers to optimize the design and implementation of these structures in their projects?
Very good. See, big steel plants are there, but the entire construction doesn't go only with the big steel component manufacturing. Along with that, you need fasteners for connection, you need fabrication units, you need prefab walling manufacturing units of various types, precasting. You need agencies, you need organizations who can do the assembly erection on the site, complete with the maintenance even responsibility. So all these things are in the, you can say, arena of MSMEs. They can be. So any MSME who wants to jump into this sector, they should immediately look at the BMTPC website. That is number one. Collaborate with consultants like us and plan to start any one of the services which I have mentioned. Subsequent to the production of the main component, till the erection, assembly and erection on site, there are at least 7 to 8 different avenues. Even construction equipment, supplying the construction equipment for shifting, assembly, erection, welding, fabrication. It's a huge area. In India, construction equipment is a sector which is not as developed, but there's a huge need of. So there is another area where MSMEs can go.
Got it. And my last question to you, sir, is what is your success mantra and how can MSMEs take advantage of that?
Country is growing fast. We need to upgrade and update ourselves with the advancements. It is not any single person's work. You have to form a team. Stakeholders can join hands, make a consortium, divide the roles, learn about new technologies from outside anywhere in the world, but develop that indigenously and jump into the construction sector with all these new technologies. I'm very much sure that anything in India, we are ready to pay money, but for good things. So anything, any product, well developed, tested, properly presented, is certainly going to have a huge market and good response from the people and government both. That is.
Absolutely. With that, we've reached the end of our episode. Thank you for your time with us today, Dr. Abhay Gupta. We've had a lovely, insightful discussion on construction technology through steel structures and prefab walls. For our audience who's attending this webinar, if you have any questions from the session, please feel free to type them in the question section on your Zoom meeting. The recording of this, along with all the previously conducted MSME Masterclass, is on YouTube on our channel, GSW1 MSME. So please subscribe and watch these episodes. Thank you once again, Dr. Abhay. Thank you so much for joining us today.
Thank you. Thank you so much for the opportunity.